Alrighty folks, in this video we're talking about inverse functions. So here we're going to be discussing some topics about functions. We're going to be using terminology about functions. So if you're still having trouble understanding functions, feel free to check our video out on functions first. So here we're going to specifically be talking about inverse functions. So what is an inverse function? How does it work? And let's see some examples. So that's what we're going to be going through here in this video. So first we have to talk about what a function is. A function, of course, is a collection of input and output values and can be represented through an equation, through a table of values, through a graph. So let's start by just looking at an example of a function here. So we, of course, know our function notation, f of x here, x being our input values, f of x describing our function, and our output values. Let's say we have this particular case, f of x is going to be x minus 1. Right? So what this function here is saying is that my input values of x, to get our output values, the function is subtracting 1 from our input values to get our output values. That's what this function here is describing. So now we think, okay, what would the inverse of subtracting by 1 be? Right? So if I were to do the inverse of subtracting 1 by 1, well, let's say we had an example. Let's say we had 3 here, and I subtracted 1. Right? How to do the inverse of subtracting 1 would be to, of course, be to add 1. Right? It would kind of undo what I did before. So if I have 3 minus 1 plus 1, I end up right back where I started here at 3. Right? So to do the inverse, would be to undo whatever I just did. That's kind of how we describe inverse, particularly inverse operations in mathematics, right? So here, my additive inverse, right? My inverse when adding is to do the opposite of that. So here, from subtracting 1, instead I would add 1. So that would be my inverse. Similarly, if I had, let's say, 3, and I was dividing that by 2, right? The inverse operation of division would, of course, be multiplication. So if I wanted to undo that, I would multiply by 2. So 3 divided by 2 multiplied by 2, I end up right back where I started again at 3. Right? So this is kind of how we describe inverses here. So we can imagine similarly in a function how we're going to be looking at inverse functions. Right? So functions do something to our input values to get our output values. So here we're going to be looking at what would get us back from those output values to the input values. You can imagine kind of jamming the product of something from a machine back into that machine to get back what you started. This is kind of the idea here of inverse functions. So here to look at this, you might see inverse functions given some function here, and they might say when f of x is equal to y. They'll say when f of x is equal to y. So what this is meaning here, of course, is it's saying we're defining our output values to also be defined as y. So I can kind of go back to my equation here on the left and replace f of x with y. Right? Again, nothing's changed here. We're just the way we're representing it. And if I wanted to, say, solve for my input values, so right now we have an equation solved for my output values. If I wanted to solve for my input values, I could move this negative 1 over to the other side. In other words, if I'm subtracting 1 here, I can go ahead and add 1 to both sides of my equation. So now I end up with y plus 1 is equal to x. Okay, now of course we could see here, like we were talking about before, the inverse of subtracting 1 would be to add 1. So what this says down here at the bottom, so we're saying if we take our output values and we add 1 to our output values, we get back to whatever input value we started with. Right? So this is here how we would find an inverse function. It's as simple as that. Right? So we kind of replace our f of x value with our y, still talking about y's and f of x as output values, right? And then just solving for that x. Right? So I have it solved for one variable, well, I'm solving it for the other variable. And the last step here is to use what we call our inverse function notation. Right? So if I have my f of x values equal to y, we use this to describe our inverse functions. To describe our inverse functions uses the notation f, and it kind of looks like it's to the negative first power. And so we say, but of course this is pronounced f inverse, is how this is pronounced. It's just the way it's represented, is to have this -1 notation for an inverse. So the inverse of f inverse of y, we would say is equal to x. And of course what this is saying here is, in my inverse function, where kind of in our world where things are backwards from what they normally are, right? We would normally see our y as our output values. Here, our y is our input to our inverse functions, and the output values are our x, what we'd normally take to be our input values and our output values. Right? So if we know f inverse of y is x, we can go ahead and look at this last form here. We could rewrite this as f inverse of y to be y plus 1. Right? So if you were given, say, given this equation here, and then looking, say, okay, what's the inverse, what's f inverse of y? This would be your final answer down here. This is just describing kind of you can almost think of it as flipping our input and our output values, right? What was up before our output values are now our input values, and vice versa. So we see down here is f inverse of y is equal to y plus 1. And this can be applied to many functions that you see. If you have any particular examples you'd like to see done out, feel free to leave those in the comments section down below.